EGNOS-based approaches will be cheaper for airports to introduce because they will not need any ground-based infrastructure.
According to the feedback we have received from the pilots, the EGNOS guidance is very smooth and comparable to ILS.
The avionics required to perform the applications provided by EGNOS are low-cost avionics.
You are allowing someone to land with vertical capability that they did not have in the past, which always increases safety.
The skies above Europe are becoming increasingly congested, as are Europe's major airports. This growth in air traffic means smaller airports also need to be safely accessible at all times, which cannot be achieved by relying solely on non-precision approaches. However, precision approaches require a substantial investment in ground-based navigation aids. But not anymore. EGNOS, the European Geostationary Navigation Overlay Service, will offer enhanced vertical precision and integrity, improving safety, accessibility, and efficiency for operators, pilots, and airports across Europe. EGNOS is a satellite-based augmentation system compatible with other GPS augmentation systems around the globe, such as the American WAAS system. WAAS has been in operation since 2003 and currently has over 1,800 published airport procedures. EGNOS is Europe's first venture into the field of satellite navigation and will be complemented by Galileo, Europe's global satellite navigation system. EGNOS improves positioning measurements using 3 satellites and a network of more than 40 reference stations in 20 countries, providing much greater accuracy than achieved through GPS alone. Here's how it works. Stations on the ground pick up signals from GPS satellites, which are then centrally processed. The accuracy of the original signals is determined and factors such as ionospheric disturbances are taken into account. These data are incorporated into EGNOS signals and sent to its 3 geostationary satellites. The satellites then relay the signals back to users. The result is substantially improved positioning accuracy and data integrity. But how can EGNOS make a difference? Most small and medium-sized airports and heliports only offer non-precision approaches. EGNOS will provide vertical guidance and can reduce controlled flights into terrain by as much as 75%.
EGNOS enhances safety by increasing the situational awareness of the pilot, because he has vertical and lateral guidance, and also by having and providing this vertical guidance reduces the controlled flight into terrain.
EGNOS can also act as a backup system for approaches into airports that already offer precision approaches and can reduce pilot workload.
EGNOS provides also an added value at ILS-equipped runways as a backup system, for instance, in case the glide path is out of service.
Another advantage is that you can do all your navigating in GPS mode. You don't need to be in VOR or localizer mode and then switch to GPS mode for en route and then back to VOR mode for the approach. You can do the entire flight in GPS mode, and that leads to lower pilot workload at an otherwise busy time during approach.
For rotorcraft, EGNOS will enable the design of flexible approach procedures specifically designed for helicopters.
When EGNOS becomes operational in 2010, it will deliver safety benefits because it will offer instrument approaches where currently only visual approaches are available, and instrument approaches are considerably safer.
EGNOS provides a cost-effective alternative to ILS Cat-1, offering similar performance without the need for costly ground-based infrastructure and maintenance.
EGNOS is perfectly suited for small and medium aerodromes because we can perform approaches close to the Cat-1 ILS of the big aerodromes without the costly ground infrastructure.
What we're looking at here is the ILS approach to Frederick, Maryland. The minimum on the ILS is 684 feet. And if I switch over to the WAAS approach to the same runway, you'll see that the minimum there is 690 feet, only 6 feet higher than the ILS, practically identical for operational purposes.
With EGNOS, lower decision heights can also considerably reduce costly delays, diversions and cancellations. This can even allow ground-based nav aids to be phased out, possibly reducing landing fees.
The airports offering EGNOS procedures will undoubtedly be preferred to those without. It's very important to increase the number of airports with EGNOS procedures and see a harmonized strategy that would make precision approaches commonplace.
There are no maintenance costs for the LPV procedure. You do not have to continuously do flight checks for an LPV procedure to keep the service maintained.
All that is needed is an onboard EGNOS certified receiver, an adapted procedure for the runway end, and an adapted flight management system.
EGNOS will enable us to cross the inversion layer, pick up the patients, and bring them to the hospital. Today we cannot fly through the high fog layer and have to rendezvous with an ambulance above the fog. This is time-consuming and does not benefit the patients. EGNOS will enable us to perform precision approaches directly to the hospital, thereby increasing efficiency and cutting costs. Most importantly, it is in the best interest of the patients.
For larger airports, EGNOS can also facilitate safe and efficient handling of ground equipment.
One of the main benefits enabled by EGNOS is the reduction in the approach minima. This reduction in the decision height can be translated into less disruptions, being delays or diversions to the alternative airport.
The increased accuracy and integrity provided by EGNOS will decrease the decision height, depending on local geography, initially to 250 feet and over time to as low as 200 feet.
We can fly the WAS to 282 feet above ground level, whereas the VOR to runway 14 and the NDB approaches both carry with them minimum altitudes of, I think, 600 and 800 feet respectively.
With an EGNOS procedure, even small and medium-sized airports and heliports will remain accessible in poor weather conditions, and EGNOS may open up approach paths to runway ends previously inaccessible due to local obstacles.
WAS provides access to airports that have an ILS on one runway end, but with a WAS signal, you can achieve precision approach on the opposite end.
Publishing EGNOS procedures will give airports a competitive edge over those only offering non-precision approaches, and will greatly enhance the efficiency of helicopter emergency medical services.
Because EGNOS-based approaches will be available in a wider variety of conditions, this will particularly help emergency services such as helicopter emergency medical evacuations and mountain rescue procedures to keep operating even when visibility conditions are poor.
When EGNOS will become available, we will be able to perform rescue flights from the mountains directly to the hospital, even under adverse weather conditions.
EGNOS also provides environmental benefits. EGNOS is really an enabler for advanced and procedures such as car procedures that can mitigate the noise around the populated areas surrounding the airports.
In many cases, EGNOS will reduce the impact of aviation on the environment. Along with reducing wasteful delays and diversions, the possibility of curved approaches and continuous descent paths will reduce both noise and emissions.
You no longer have to do step-down approaches where you descend and level off and descend and level off. You can do smooth, continuous glide path approaches, almost identical to the way you would fly an ILS.
For helicopters, EGNOS will allow approach procedures to be developed from any direction, thereby avoiding densely populated areas.
One of the benefits of point-in-space approaches is that helicopters will be able to approach an airport from any direction, and therefore will be able to keep away from houses as much as possible.
EGNOS is the perfect solution for 4 sectors in aviation: regional airlines, helicopters, corporate aviation and general aviation, because we can perform advanced operations with low-cost avionics.
If 2 airports side by side and we had a WAS approach and our neighbor did not, there's no question that it would increase the traffic here.
The EGNOS signal is free and is here to stay. EGNOS is set to be certified for civil aviation in 2010, and its geographic reach will be extended. EGNOS-enabled equipment is widely available, with over 40,000 aviation receivers already in use. EGNOS can provide accessibility, safety and cost savings in a single proven solution, by delivering high precision with a low investment.